Hi, I'm Dion from legalcert.mathsvideos.com. Now for this question here we're asked to find the asymptote. So the asymptote is basically a point that leaves either x or y undefinable. So in order, what will make here, so we'll go over the x term first. What value for x would make y undefinable? Well, if x is equal to 0, we'd have pretty much, negative 1. We'd have 2 all over 0, which means y is undefinable. So we'll just show that here now. At x equal to minus 1, that implies that y is equal to negative 2 all over 0. Now, y is undefinable at that point. There's no value for y that's going to equal the value on the right hand side. So that means that's going to be your asymptote at x equal to negative 1. That's your asymptote there. Now, that's one asymptote. That's your x asymptote. We also have a y asymptote. So we have to go what value of y will leave x undefinable. Well, what we can do is here we just multiply both sides of the equation by x plus 1. So we have y times x plus 1 is equal to 2x. Yeah, times x plus 1 over x plus 1. So basically, what value of y here is going to leave x undefinable, or basically leave the equation kind of undefinable? Well, a lot of you might have spotted it already. It's actually when y is equal to 2. That leaves with 2x plus 1 is equal to 2x, which means like y is actually undefinable there. So add x equal to 2. So the equation of our asymptotes really, that's y equal to 2, sorry. So the equation of our asymptotes here is x equal to negative 1 and y is equal to 2. They're the equation of our asymptotes. Now we're also asked to find coordinates of q. Now to do this we have to actually get the derivative of the equation because we have to find the slope of the tangent first. So our original equation y equal 2x over x plus 1. Y is equal to 2x all over x plus 1. Now we want to find the slope, we want to find the slope of the point P. So dy dx. Now we'll let this equal to u over v. Now you should know this, dy dx is equal to b times du dx minus u times dv dx all over b squared. So now that implies dy dx is equal to, move there, dy dx is equal to v, which is x plus 1, times du dx, which is just equal to 2, minus u times dv dx, which is minus 2x, times dv dx, which is just 1 all over v squared, which is x plus 1 all to b squared. Now dy dx. We will extend the page. Now, dy dx, just hiding this up slightly, is equal to 2x plus 2 minus 2x, which is just 2 all over x plus 1 all to b squared. I'll write that down as x plus 1 all to b squared for now. So now we're told that the coordinates of P are 1, 1. P is 1, 1. And the slope at P is also the same as the slope at Q. So if we find the slope at P, then we just put that into our slope formula and that'll give us another value for x, and that'll be the Q coordinates. So at P equal to 1, at x equal to 1, our slope is equal to 2 all over 1 plus 1 all to b squared, which is 4, which is a half, which is sounding right to me so far. So now, we have our slope formula here, dy dx is equal to 2 all over x plus 1 squared. Now, we know that the slope of the 2 points is equal to the same, the slope is equal to a half. So this is our slope here, we're going to let that equal to a half. So that'll give us the value for x, which makes this possible. So we multiply both sides by x plus 1 squared. We basically cross multiply. 4 is equal to x plus 1 all to b squared. We can get the square root of both sides. That implies 2 is equal to the absolute value of x plus 1. And that implies the value of that gives minus 2. Or x equal to minus 3. That's the solution there. I'll just work that out a different way, just to double check. X squared plus 2x plus 1. That implies that x squared plus 2x minus 3 is equal to 0. And you factorize that, you're going to get x plus 1 times x. X minus 1 times x plus 3 equals 0. And that implies x equal to minus 3. Yes, that's right. There should be 2 ways of doing it there. So x equal to minus 3. So we have one coordinate of q. Q is equal to minus 3 comma y. So we know from our original equation y is equal to 2x all over x plus 1, as far as I can remember. Yeah, y is equal to 2x over x plus 1. So then x equal to minus 3, negative 3 I should say, is equal to 2 times negative 3 all over negative 3 plus 1 equals negative 2 equals negative 6 all over negative 2 is equal to 3. So what that implies our y value here is equal to 3. So q is negative 3 comma 3. Now for our third part here, we're to verify the point of intersection of the asymptotes is in the midpoint of PQ. So we're going to find the midpoint of PQ first. Now we have our q term here, it's negative 3 comma 3. And that's q, and then we have our p term here is 1 comma 1. Now we should know our midpoint formula here. We'll just let this equal to x1, y1, and that equal to x2, y2. Now our midpoint here is, midpoint formula is x1 plus x2 all over 2, comma, y1 plus y2 all over 2. That's our midpoint formula there. So basically x1 plus x2 is equal to negative 2 all over 2, comma, y1 plus y2 is equal to 3 plus 4 all over 2, 4 over 2. So that implies that the equation of the asymptote is negative 1, comma 2, which is what we started off to begin with. The equation of the asymptote was negative 1, comma 2. Just double check that. Yeah, negative 1, comma 2. That's the solution to that question. Now, if you found this video useful, please add me on Facebook, Twitter, or YouTube. The links should be on your right hand side. Alright.